All right, we're team 6, corporate event extraction. I'm Liren,
I'm David.
And I'm Tianxiao.
and our mentors are Swapnil and Yuval.
First, let me do an introduction for our task. We are given text of corporate events from the web pages and extract and normalize the fields of the events. The events field is like this. For example, company, physical year, physical grade, event type, event date, and the time and time zone. Next slide, please. For our motivation, publicly traded companies are required to report earnings and hold certain types of events. During these events, stocks are most volatile. Huge interest among analysts, investors, shareholders, and journalists. Event-driven huge fronts gained 7.4% compared to 4.7% for all strategies in Q1 2021. Next slide, please. So our background, the named entity recognition is the information extraction to find and classify named entities in unstructured text into predefined categories. And we use the transformer-based large language models like the BERT, the Robota, and the GPT NEO. We use the existing NEO models like Stanza and the Space. We also use the regex. Next one, please. And for our transformer models, the BERT is a bidirectional training of the transformer and deep sense of language context and flow than single direction language model. The Robota builds on the BERT's language masking strategy, but trained with much larger many batches and learning rates, and trained on an order of many gets more data than BERT. And the GPT Neo is an open source author of the GPT-3 model by the Elusa AI. It uses the mesh TensorFlow library to expand to the full GPT-3 size and supports various GPT-3 functions.
So what we're proposing to do is to create a pipeline to extract these corporate entities from announcement information and then normalize the fields. We also want to create and label a data set of event announcements from 500 corporate websites that we got from our mentors. And that's mainly because a lot of the corporate related event data sets that we find online aren't free, and so we can't really use them. Here's a kind of a design overview on our pipeline, where our inputs are the event text, and then it goes through various extraction methods to get a label. So we started out using regex and like off-the-shelf NER models to get a baseline. These off-the-shelf models were from Stanza or Spacey. And we found that for some entities like fiscal period, fiscal year, and time zone, regex and Stanza showed promising results without us having to use any other models. And we think it's because for these entities, there are like a limited amount of possible combinations that appear in the event text. So that's why using kind of these methods, it worked well. Later on, we also tried to use a QA model to extract entities like the date, time, and company names. So again, we first tried to use like a pre-trained QA model from Allen NLP, and this worked pretty well with date and time. But it was lacking in finding the company names. So we decided to fine tune the Roberta model on our training data, which was about 700 examples, to improve on the extraction of the company names. And how we used the QA model was basically just using the event text as the context and then changing the question that's asked depending on the field. And an example of that can be seen in this kind of picture where we have some kind of text and then we ask a question and we hope the model to can extract these kind of answers.
For the event type, we also found that regex was not good enough. So we fine-tuned a BERT model to extract the event type. And this was done using a pre-trained BERT model and then adding a text classification layer at the end to basically just classify the outputs into one of our predefined event types. And we tried several different pre-trained models. And how this fits into the pipeline is that we train this model and then we save it, and then in the pipeline it's called, and new entries from the pipeline are fed in, and the model will predict output. Next slide.
And then we also use the GPT-NU model for the event type. We fine-tune the GPT-NU model to extract the event type. We approach this as a text generation problem where the event text is fed in and use the model to generate the event type. And we use the two methods. First one is priming. It means do not change the pre-trained GPT model and provide additional predictions before the question, and the other one is the fine-tuning. It means it's other new outlier to the pre-trained model, and we use the 125 million and the 100 and the 1.3 billion parameter models for the fine-tuning, and the 1.3 billion model for priming only. And the generated categories still need to be classified. Next, please.
So for our data, we started with the 500 URLs of company event announcement pages. And because of that, there wasn't a consistent format for the events. Like some companies listed in tables, some of them had it in events. And this also means that the data was raw and didn't have annotations for the fields we wanted to extract. So we had to all do that ourselves. So we started by manually annotating a few of them to just get a better understanding of the annotation process and for initial testing of some of our regex models. And then we had to later transition to Apen for the crowdsourcer annotations to just be able to get more data. And on the Apen platform, we created 2 jobs. And the reason for this was to make each job simpler and also to check in between the jobs for quality. And the first job was to extract the raw event text from websites. And the second job was to annotate the extracted text with our fields. And because we set up these jobs, we are able to get like thousands more rows of data for each job within a few days if we decide to launch more rows. But that would just cost more money. But for now, we just have 1,100 fully annotated event text, and we split them into our trained dev and test sets. Next slide. So as you can see on the picture, it's an example of our first job on the Apen crowdsourcing platform, where annotators just copy the text of the event from the URL given to them, and they copy it into the Apen platform. And next slide. And for the second job, it takes the text that the annotators copied from the first job, and this time it wants them to annotate each field. So it's like a small fill in the blank or radio menus for that. Next slide. So for our experiments, we started off experimenting with off-the-shelf NER models, and then we transitioned to creating our own regex models, and then we use transformer-based models for things like BERT and GPT Neo and RQA models. Next slide. And then for evaluating performance, we used micro F1 score for each field. And for our scores, they also exclude examples where both the prediction and the goal label were none. So for example, if the company name goal label was none and our prediction was also none, that score would get excluded from the calculation. And we also had to standardize entities from the text, so things like the date and time. And we also use fuzzy matching for company names because the strings don't always match up exactly. And in addition to doing evaluation per field, we also evaluated the field for the whole tuple for the event. And that was done using the exact match score between 1 if all the tuples match and 0 if not. And just as a note, our models are trained on crowdsourced data, so there might be a potential degree of error. Next slide. So this is our results slide. For things like event type, the BERT model does the best. And as you can see, it does around like 6% better than the regex model. And for other models, there are mostly in the 90s, except for the fiscal year, which we'll talk about later. And they're mostly using either the QA models or our regex and model. The next slide.
So we also made some diff files for each entity so we can analyze our errors. We noticed that there were some mislabeled annotations, so we had to go back and manually inspect the annotations. So in terms of errors, some common ones were that for event type made by the BERT model, it had trouble with different types of conferences. And this kind of error occurred like 95% of the time, where like something like an example is like company investor conference. It's actually should be like a shareholder meeting, but it gets confused like on the investors if it's like if it's for investors or it's about like investments kind of. And other entities for like time and date, we didn't specify to annotators what time to label when there was a time range. So examples for like if there's a range from like 4 to 5 p.m. of the event, our model would predict like 4 p.m. while some annotators would mark the end time. And for fiscal year, because we kind of went with a rule-based approach, it's still hard for us to distinguish between fiscal year and the normal year. And for a company, our model has trouble with like when the company names are people names or abbreviations.
And then for the event type for GPT, the fine-tuning is better than priming, especially when there is more data. And we found that the data format is important for GPT models. And the generated categories required logic judgment rather than directly comparison of the similarity. For example, the financial conference call will be considered as a earnings call instead of conference. And for the crowd source annotation, it is easy to expand the dataset with this way, but can be fairly costly. And it has the accuracy issues. We had 2 iterations for the job 1, and the public crowd was less accurate than the Bloomberg one. It's about 33% low algorithm scores. Next, please.
So in conclusion, we built an end-to-end pipeline to extract event information from event text and normalizing that data. We also produced a annotated corporate event dataset that can be made publicly available. Some future works that we could do is to improve our extraction techniques so that we can extract the event information directly from the URLs. And to do this, we probably need like a relation extraction model to be able to handle like multiple events in a document. And we could also expand on our event data set so we can have more training data to improve our models as well. So we will go over our demo now.
So for how our pipeline works is we give the input file, so which is basically just the list of the event text, and that will go into our pipeline, which we have configured to use our best performing models from our experiments. And then that will output the fields for each of the entities we want. As you can see, it generates all the fields we want, like the company, fiscal year, and so on for the event text that was fed in. And then we can also have it evaluate scores depending on the input file, if you give it an input file with the labeled entities or not. And yeah, now we're gonna give like a live demo.
So yeah, this is our GUI of our pipeline that does only one event at a time, just to see everything more clear. So we have this text right here where we can see that it extracted like the company name, fiscal year, fiscal period, event type, date, time, and time zone. And then we can try it on a different text by putting it in here. It should take a few seconds. Yeah, so this is the new extracted information. So we see that it said that the company name is the Cohen. I don't think there was a fiscal year in this text, so it returned none. And then for fiscal period, because this is an annual event, our label for that is Y, and then it's a conference type, and then the date and time zone. And we can try some another one that where model kind of fails at is when, like as mentioned before, like when there's a range in the time or something. Our model would extract the first time, maybe not the full time, I guess. So this is one where it kind of fails on the time, but it does get other areas correct. Yeah, that's pretty much it for the demo.
Okay, thank you, Team 6, for the demo and your slides.